All right. Hello, everybody. Welcome back. We are going to be going through quiz 12 and 13. Let me share my screen here, and I'm going to give everybody else screen sharing just in case. And I've only been able to get through a couple of these myself. We're going to have to work together. But we'll get through it. And then at the end, if we can have, it'd be nice to have a couple new volunteers for the canary role. You know, once we do our due diligence and get through this as thoroughly as possible, get a couple early submitters so we can kind of gauge our progress. We all have to take the turns, and statistically, it's a pretty well distributed risk across the group. But let's get into it. For number one, it asks, what is bagging known for? And so far, I've been able to find sampling with replacement on slide 13 of the Ensemble PDF. But I wasn't able to find mention of any of the other ones easily. Not saying they're not out there, but does anybody have the same question and the same answer or something different?
I had that answer too.
Outstanding. As long as you have it, Bailey, I'm okay. I always feel better when our answers match.
I had put all of them.
You
I
did
had
all?
it.
Oh man. Tell us
Yeah,
about it.
Yeah, where'd you find them?
give me a sec.
I'm looking, I've got all the PDFs up and I got the PowerPoint up, so I'm trying to flip through them and see if I can find anything. It talks about weak learners into single strong learner or sequential method. Now the sequential method kind of makes sense as far as the sequence of operations.
The combining multiple quick learners, that is for ADTA boost.
That's ADTA boost,
Yeah,
but that's not bagging.
not backend. The backend I found is only sampling with replacement. I could not find for the sequential.
Well, let's see what Christian has for a source before we start shooting them down. Because I gotta say, I've questioned Christian too many times and been proven wrong.
Yeah, Tony, the first option is also correct. Means I was not able to find the second option, but first is correct and third is correct. In that sense, I selected all of these.
So you found the first and third, but not the second. But because of those two, you chose all of these?
Yes, yes.
That's risky, man.
But first one is correct, right? This is the bagging, right? That combining the weak learner into a single strong learner. That's the process.
Can you point us to where you found that?
Okay, let me check.
You know us, man. We need to have an ironclad source before we just start accepting things, or else we'll argue ourselves into a frenzy.
I found a definition of sequential analysis. It says in statistics, sequential analysis sequential hypothesis testing is where a sample size is not fixed in advance. Instead, data are evaluated as they are collected, and further sampling is stopped in accordance with a predefined stopping rule as soon as a significant result is observed.
Where is that, Bailey?
It's just Google.
Oh, okay. All right. So with all that you just read, did that mention sequential method?
It says sequential analysis.
Sequential analysis, okay. See, in the book on page 313, under the bagging section, it doesn't say anything about
Yes, Tony, you are correct. Actually,
That sampling with replacement?
yes. Let me ping you one URL.
Yeah, because I'm taking that from
Can you
This-
open that URL?
this slide 13 on ensembles that create M samples of in data with replacement, but
Hmm.
there's nothing else in there about the weak learner, strong learner, even when you get into
Yeah.
bootstrap.
I pinged one URL. Can you open that one?
Say again, Sajal?
I just I pasted one URL in the chat. Can you open that one? And you can go to boosting or search with sequential.
You're kind of going in and out, man. I'm sorry, I'm having a hard time hearing you.
Let me present my screen.
Okay, all right, let me stop sharing. Go ahead.
Yeah. So yes, the boosting is sequential, and boosting is like weak learners, and the sequential in every adapter.
Okay, so yeah, and that's what Mintu was saying, was that the ADTA boost was more about the boosting is sequential. Okay, but so okay, I get it. So the boosting is the combining weak learners and the sequential method, but the bagging is the sampling with replacement. So Christian, for number one, did you?
I think that's the exact website that I was looking at whenever I had answered that.
What was that?
I think that's the exact website that I used to answer number one.
Okay. So what was it about this website that made you say that it was all three?
This is a very famous website. But Christian, that yeah, I was earlier thought so, but you can see that that in boosting, sorry, in the bagging, it's a parallel, not sequential.
Yeah.
And sequential is boosting.
Okay. All right, gotcha.
All right. So then are we cool then on number one being that answer for that question, that we're talking about sampling with replacement for bagging? Because I really don't like questioning Christian. He's always, I mean, he's proven me wrong more than I've proven him wrong. But I'm going to flag that. We'll come back to it, just the final review. But right now we've got pretty strong collaboration from about 3 or 4 different people and a couple different sources that sampling with replacement is the bagging, and the sequential and the combining multiple weak learners is the boosting. But we'll come back on that one. For number two, I have which of the following is not an ensemble technique, and I'm choosing decision tree because it is the only one of these three, or of these four. All these other three are ensemble methods, and this is kind of a standalone decision tree. Does anybody have anything different or any reason why that would be a wrong answer?
I said the same.
Okay. Outstanding.
Also, Tony, I put in the chat a website that had most of the questions, or at least on my quiz, at least.
Okay.
Yeah, I found the same thing, Christian.
Okay. All right. So yeah. Let me bring it up here real quick. You're talking about this one, 40 questions asked.
It does make sense to decision tree, because the decision tree is just one tree as opposed to ensemble, which is a bunch of trees.
Yeah, that's what I was thinking. All right, cool. And I feel confident about that one. So then on to number 3. Which of the following, does anybody have a different question for number 2 before we go on?
Hmm.
All right. On to number 3 then, which of the following best describes the proper approach to use the learning rate to get an optimum output in the boosting technique? And that's kind of where I was looking.
So here I have selected the first one, but I have doubt between first and fourth one.
Okay, so you're torn between 1 and 4.
1 and 4.
Okay. Does anybody else have any corroboration on either or both of those?
For your 1 and 4?
Well, okay, fair. Do we have this same answers in different order?
No, mine are the same.
All right, Sajal, are your
No,
answers in the
all-
same order as mine?
Yeah, same order.
Okay.
I
So
was
then
thinking between 3 and 4.
3 and 4. So, okay, so we have 1 and 4 or 3 or 4. So right now 4 has
was-
more votes.
I was thinking 3 and 4 too. I know for sure it should not be the extremes, because if it's too low, then it'll take too long to compute, even though it'll be very accurate. But if it's too high, like if it's extremely high, then it'll be too fast and not accurate at all. So you want it in between extremely fast and extremely low. But I don't know if it should be like, I guess, medium low or medium fast.
Yeah, that's a.
Hi guys.
Hi, Miriam. How are you?
Good. Sorry to join in late. Got stuck at work. I
That's
am
all right.
doing
We're recording the session. We're only on question 3, so you haven't missed anything. So you're in a good spot.
okay.
We're going over question 3. We're talking about the learning rate to get an optimum output in the boosting technique. So if you have any insights on boosting technique learning rates, feel free to throw them at us. Otherwise, we're all looking frantically in different areas for something that resembles an answer.
Let me go ahead and open my quiz to double check what it's asking exactly for boosting. Okay.
The whole point of boosting is to get a higher accuracy, is it not?
Yes, it is. So that
That's
kind of
correct.
that
That's
back
correct.
propagation.
So then would it make sense to want a low learning rate? That way it'll still be more accurate.
It's kind of where I'm leaning. Yeah, I think with all the stuff going on, the faster it goes, the more the higher the propensity for error. But if it's slow, like good barbecue, slow and low, then I think we'll get a higher accuracy out of that process. So
That's a good
yeah, I'm kind of with you on that. Should be low, but not too low, right?
Yeah, that's what I originally had.
Yeah. Anybody have any problem or any heartburn with that? Then if not, we're going to move on to number 4. If you have any brain spasm that tells you something different, then we'll come back to it. Number 4, can ensemble techniques be used for both regression and classification? And I kind of wanted to say that yes, but it depends on the learners from something I had seen earlier, and I'm trying to find that. It is used for prediction, regression, and classification.
Isn't prediction and regression?
They
Yeah,
can be used for both.
yeah. Now, is that caveat, is there a caveat in there about the learner, or did it just a simple yes?
I didn't see that,
Okay,
or I didn't understand it that way.
all right. Then it may be something that I just picked up on. I'm gonna flag it for right now, but I've got a couple consensus for yes. I'm just
For
getting.
number 2, did you guys say decision trees for
Yes,
the
decision tree.
non-ensemble technique?
Decision tree, yeah.
Okay, that's okay. Good.
All right, I'm not seeing anything immediately to contest the whole ensemble of the regression and classification. I think it is yes, without the caveat.
I think she's trying to trick us with that, but it's a yes or no question. You know, it's not a hypothetically speaking
Yeah,
question.
pretty binary, right? Either 1 or 0.
I was just looking at the chapter 13. I don't know if that's what you saw, 220.
Chapter 13 in the book.
No, the multi-methods PowerPoint,
Oh, yeah. Let me bring that down.
slide 5. Sorry, not slide 4. The first sentence on top of that part.
Multiple methods are used initially in predictions, classifications. Yeah, so yes, predictions, classifications, yes, but still no justification for the caveat about the learner. So yeah, I'm gonna just stick with the yes straight up. All right, cool. Then I'm gonna take that flag off because I'm feeling more confident about that. Number 5 is alive. Which of the following statements are correct regarding benefits of an ensemble model? An ensemble. Better performance, generalized model, and better interpretability. Yeah, it's like they're all good answers.
Why is she like this?
Better performance, generalized models, and better interpretability.
Okay, so I'm looking at the website Christian shared.
Okay.
And it says C 1 and 2. And it says 1 and 2 are the benefits of ensemble modeling. Option 3 is incorrect because when we ensemble multiple models, we lose interpretability of the models.
And it's on page 47 of the ensembles deck. It's listed as one of the disadvantages.
Could you guys resend the link? Whoever sent it. Sorry to interrupt.
The link for the website,
Yeah, for that website. I was trying to.
I'll put it in there right now.
Thank you so much. Oh, got it. Thank you. Sorry to interrupt.
No
I think
problem.
that makes sense too, because ensemble, you're getting a collection of forests, and the one problem with having multiple forests is that you may overfit, and overfitting makes you lose interpretability.
All right. So which one of these then fits with all that stuff that all y'all just said while I was trying to catch up with where you are?
1 and 2.
1 and 2?
Mhm.
Because we're losing interpretability with the ensemble, with the combination of the ensembles, right?
Correct.
Okay.
That's why we're not choosing it.
Okay. I am happy with that. I am writing this down so I know what the heck we just said. Cool. Then number 6, which of the following can be true for selecting base learners for an ensemble? Different learners can come from same algorithm with different hyperparameters. Different learners can come from different algorithms. Different learners can come from different training spaces. Different learners. Base learners. Where did I see base learners? All right, I see the chat. Mintu, there's no option for 1 and 2.
That was for the
Yeah.
previous problem.
Okay. I got you. That's, I heard the chimes and I thought the chat was coming in. My bad. Never mind.
This one I go with number 2. That's
Number
what I
2?
found. Yeah, I go number 2. I haven't found the other one yet.
Okay. Where did you find number 2? Or
I know I read it somewhere. And
okay, yeah, I know that's.
and I cannot remember right now.
I will say that this question is on the website that I linked, but I have no idea for the explanation.
Okay, where on this website?
Just Control F it.
Don't say F it to me. What were we looking at? What was it?
Which of the following can be true?
Oh, for base learners, right? Yeah.
Yeah.
True or false, parallel, no. Okay, there we go. So which of the, oh, wow, that's like the exact question, isn't it?
Yeah.
Base learners for the ensemble, and they're saying it is D, 1, 2, and 3, all the above.
I just have no idea why.
Well, we can create an ensemble by following any all, so that is very straightforward. All right, well then, what is this site? This is analyticsvidhia.com. Does anybody know if this person is sane or on drugs when they did this? Can these answers be?
Maybe the point is just to realize that you can combine so many different types of models.
I can accept that.
I don't like this question at all, though.
I know. Well, I mean, I really don't like any of them, to be honest with you. There hasn't been a straightforward question in, like, 3.5 years.
I was about to say in like 6 weeks. I also hate that almost all of these are like 1, 1 and 2, 1 and 3, 2 and 3. Those are so hard.
It
to
sounds like
narrow
a dance. Like we're teaching how to dance. 1, 2, 3, 1 and 2, 1, 2, 3.
Exactly.
Isn't that right, Jordan? Tell me, buddy.
He is ready for bed.
Oh, me too, man.
Me too.
Same.
All right. Well, let's try to get this done and then, release the Kraken. Ensembles, true or false? Ensembles will yield bad results when there is significant diversity among the models. Note, all individual models have meaningful and good predictions.
I think you
So
skipped
if
it.
Yeah, I think you skipped 120.
Oh yeah, I guess that was wishful thinking. You're right. Trying to get over faster than it should be. True or false? Ensemble learning can only be applied to supervised learning methods. That does not sound true to me. In the book or in the website on question 6, it says false. Ensembles will yield bad results when there is significant diversity among models. be false. An ensemble is an art of combining a diverse set of
You're
learners.
looking at a different question.
God darn it.
That's the next question.
Yeah, you're right. I'm gonna go and put false for that because I believe that. Ensemble learning can be applied to supervised learning methods. Supervised learning methods. Supervised learning methods. True or false?
I would just type it in.
I
'cause
know.
there's 40 questions on there.
Okay. Oh. Okay. So still, ensemble learning can only be applied to supervised learning methods. False, because generally we use on, this is the right question, right? I'm not, yeah. We use ensemble technique for supervised, and you can create an ensemble for unsupervised. So yay. Or at least it validates my belief. Whether it's right or wrong, we'll find out. But anybody have any arguments against false for 7 and 8, since I've like little Mr. Johnny on the spot, excited?
Not me.
Okay. If Bailey's happy, I'm happy. And Christian and everybody else who's usually more right than I am. So then, numero nueve. Which of the following is or true about weak learners used in an ensemble model? Another one. Megan, you jinxed me, man. It's all 1, 2s, and 3s. Which of the following is or true about weak learners used in ensemble models? They have low variance and they don't usually overfit. They have high bias, so they cannot solve hard problems. They have high bias, so they cannot solve hard learning problems. That one's worded weird. I mean, weirder than the average, which is pretty weird. They have high variance and they don't usually overfit. I'm going to call BS on number 3. But let's see. All right, which of the following is or true? This question is answered in that website, that magical, wonderful, hopefully not full of BS website, where it says are true about weak learners, and it says both 1 and 2. They have low variance and they don't usually overfit. They have high bias, so they cannot solve hard learning problems. It still confirms my BS flag on number 3. So weak learners are sure about particular part of a problem, so they usually don't overfit, which means that weak learners have low variance and high bias. I'm okay with that. Is anybody not okay with that? Does anybody have anything that ties these answers back to our actual reading material, or are we going to be going off of an oracle? 'Cause
All I'm gonna say is that I believe in the internet. It's powerful. That's all I gotta say.
Yes.
No, I fully agree with number one. Number two, I would say yes, but I'm not confident.
If you hadn't seen the answer, and would you have considered number two?
Yeah, well, what I'm okay with number two is like the fact that it has a high bias, just that last part, I don't know.
Yeah,
Like so they can solve hard learning problems. That's kind of what I was conflicted about.
yeah.
Okay, I found somewhere, I read somewhere, it's saying that boosting reduced bias by training quick learners sequentially. That's what I have. So I don't know, maybe it's for number two.
That boosting eliminates high bias by
Training quick learners.
training weak learners.
Uh-huh.
Yeah, okay. So then does that confirm or negate number two? I'm having trouble with the wording of that.
Reduce bias. I know it's reduced bias, but it's the word high bias.
Boosting means combining a strong learning algorithm in series sequentially to achieve a strong learner from many sequentially connected weak learners. Which of the following are true about weak learners in an ensemble? They have high bias, so they cannot solve hard learning problems. Boosting means combining. Boosting is an ensemble. To achieve strong learner from any sequentially. So there's nothing about the bias really in there, but I know it's a factor of it. Hypothesis, ensemble learning collection, decision trees, best classification. No free lunches when combining multiple independent diverse decisions.
I just found a blurb somewhere else on the internet, but it says that since individual weak learners are too simple to overfit, so that helps, I think.
Yeah. Yeah, I consider that some corroboration. Unstable learners decreases the error by decreasing the variance in the result due to unstable learners. Algorithms like decision trees and neural networks whose output can change dramatically.
Tony, look on Ensembles PDF on slide 24. The bottom bullet point. I have a focus on difficult examples which are not correctly classified.
Focus on difficult examples which are not correctly classified in the previous steps. And this time about high bias cannot solve hard learning.
What does hard learning mean? Like complicated? Like
Yeah, complex machine learning processes.
okay.
So I'm okay with what are 1 and 2? Is that 1 and 2? Yeah. Abhirag just checked another site and came up with confirmation for 1 and 2. So I think we can go with it. We've got confirmation, we've got corroboration, and still, you know, number 3 got weeded out, and no one's come back and said anything about that. So I think we can. I think we can accept that. If anybody has any heartburn, we can come back to it later on our final walkthrough and discuss it more. But otherwise, everyone cool with going on to number 10?
Sounds good.
All right. Ensemble of classifiers may or may not be more accurate than any of its individual models. I believe that to be true. The accuracy can be more or less accurate. And I remember that from the reading. Just what page? It was in the book. Can improve predictive power. Equivalent to variation and prediction error. Number 311, page 311, the variance can be lower than each of the individual variances. Under some circumstances, the key component is a covariance. Correlation between the 2 prediction areas leaves us with a quantity that can be smaller than each of the individual variances. Using average of 2 predictions can be potentially lead to a smaller error of variance. Simple averaging, combining classifications, ensemble of classifiers may or may not be more accurate. I know that to be true. I feel it in my bones. Gagging, uplift, persuasion modeling.
Found it on page 313 in the book,
313.
where it says the wisdom of crowds. I think it was also in one of the PowerPoints that she put
Okay.
at the very bottom of that wisdom of crowds summary or paragraph. It says an ensemble estimate will not always be more accurate than all individual estimates in all cases, but it will be more accurate most of the time.
Okay. That's what I saw then. That makes me happy. I'm gonna stick with that. I'm calling number 10 true. If anybody has anything to say about it, let me know. But I think that's my gut talking. Number 11. Which of the following is true about weighted majority votes? And I just saw majority rules on page 312. And votes, where was votes? Weighted majority votes. Voting is on page 312 under combining classification. All right. We want to give higher weights to better performing models. That's not true. The models don't need the weights. The better performing models don't need the higher weights. They can work off of the lower weight. Inferior models can overrule the best model if collective weighted votes for inferior models is higher than the best model. I don't believe that to be true. And voting is a special case of weighted voting. I don't believe that to be true. Under combining classification, in the case of classification, combining the results from multiple classifiers can be done using voting. For each record, we have multiple classifications. A simple rule would be to choose the most popular class among these classifications. As in prediction, we can assign heavier weights to scores from some models based on considerations such as model accuracy or data quality. This would be done by setting a majority rule that is different from 50%. And I don't remember anywhere where it said that the higher weight had to go to the better performing model. So I'm inclined to say none of the above. Especially since we haven't had a chance to use that option for all these 1, 2s, and 3s yet. So it's kind of my own little rationale, but
I don't know what number 3 is. Is that just like a typo? Or did I miss something?
what do we, the
Like
third option in number 11? What would be the typo?
I guess like voting is a special case of weighted voting. I don't know. I just don't understand the sentence.
Yeah, I maybe it doesn't make sense. Therefore, I'm saying it doesn't belong there. Therefore, I'm saying none of these.
I don't trust it.
I don't, not at all.
I'm cool. I'm cool if you say that, but I'm just going to point out the website says all of them.
Wow. Well, I originally had 1 and 2 and didn't understand 3 because I thought like at the end of the ensemble, you could like pick out, like if you have one really awesome model that you like the way it thinks better than the others, you can weigh it in more, but you don't want to lose some of the information that the, less accurate models contribute. So you can keep them, but just like turn them down a little bit. So that's what I was thinking about when I did 1 and 2, and I only didn't understand 3.
It says all of the statements are true.
Yeah, so it's not really giving an explanation. So that's why I'm not too sure if we want to trust it.
Yeah, I'll flag it and come back. I can't trust my rationale. Everything else.
I learned something for number 9. So there's always a bias and variance trade-off. So if we agree that number 2 is definitely true and it has high bias, then it also has to have low variance. So it should be 1 and 2.
Okay, all right, that's great. Where did you see that, Bailey?
The internet.
The internet.
Sorry, Tony.
Are any of these answers actually coming out of our reading of the book? I mean, I feel like the internet is the savior of the day here. I'll take it. I'm with Miriam. I mean, the internet always wins, Megan. You're right. You're right. Okay. All right.
So then we are saying all of them?
We're saying all of them.
Okay. Interesting. All right.
Yeah. I'm shutting my my blinders off, and I'm gonna open my perspective a little bit.
All I gotta say is technically the internet has every single PhD you can imagine. Did they get it from Harvard? No, but
You're right. You're right. But is this website made by a PhD or?
actually, let me see.
And Ankit Gupta. Is Ankit Gupta a doctor somewhere?
Okay, so according to his bio, he is currently working as a data scientist at UBS who has solved complex data mining problems. Let me see.
All right, well,
I mean, he seems like a kid in his picture, not gonna lie.
I'm not gonna judge anybody by anybody's intelligence by their age, because there's a lot of really, really smart people who are younger than me.
See, there you go. Then we're gonna go ahead and trust the internet.
Okay,
Here
thank
is
you
his
very much,
bio.
Ankit Gupta. I appreciate your work here. Which figure represents stacking? Stacking.
I initially wanted to go with 2 just because of the way it looked.
And I agree with you. I think number 1 is a little bit kind of too literal or too on the nose. I think it's more of an evolutionary process than a hierarchical diagram. But it'd be great if there was a picture to,
There is.
Is there
It's-
where?
It's in the slides for one of the videos. I watched it today and I had originally picked 2. I don't know. I liked the picture too, but then I saw the picture and it's 1.
It is
Um,
1.
Yeah, I believe so. The website says 1.
Website says 1.
It really does. I'm not joking.
I believe you. I do. At this point, I believe anything. I think old Ankit Gupta was onto something here. Yeah, okay. Which of the following stack A? It is aggregating the results of the base models by applying a function f, you can say a model, on the outputs of D1, D2, and DL. All right, so Ankit Gupta, I don't want to say, is that a male or a female? You say that as a young boy? A young male type person, Miriam?
To be fair, he disappeared from the internet in like 2017, so
Okay, well.
maybe
I
he
mean,
knew too much.
maybe he knew too much. The statistics cartel got a hold of him. They shut him up. Yeah.
Yep,
Anybody that makes statistics easy is a threat.
that is true. He
Yeah.
was too powerful.
Wondering, it says A is correct because it is aggregating the results of base models by applying a function f, you can say a model, on the outputs of D1, D2, and DL, in case you were curious.
Yeah, I saw that. Okay, yeah. Thank you, young Ankit, and Megan and Miriam and everybody else. So, on to 13. True or false? In boosting, individual base learners can be parallel. I want to say yes to that. That rings true in my ears. But in the website, Ankit says it's false. In boosting, you always try to add new models that correct previous models' weaknesses, so it is sequential. False. I agree. I'm okay with that. I understand that. I was thinking more architecturally than functionally, so that I see the error of my ways. Okay. 14. Match the following statements to the appropriate ensemble method. And we have, okay, 2 questions and like 300 choices. So bagging, cascading, boosting, averaging, random forest, and the same down below. So the ensemble approach helps to avoid overfitting by modeling different data samples separately and then combining. That's got to be bagging, bootstrap aggregating. But that's my initial.
But it's,
Yes.
I think it's sampling. This looks like it's sampling without replacement because you're modeling different data samples separately. And I think that bagging is sampling with replacement.
Okay, let me.
Maybe.
In the book, No, where's that slide? Where's that PDF? Where are you? Ensemble. Oh, I really wish it's like that memory card game. I'm trying to remember like what I play with my daughter, like where strawberry shortcake is. Trying to remember which slide I saw what, where, and when. It was the bagging. Create M samples of in data with replacement. Modeling different data samples separately and then combining. Or by modeling different data samples separately and then combining. That sounds like bagging to me. Generate multiple random samples by sampling with replacement from the original data. It's called bootstrap sampling. Running an algorithm on each sample and producing scores. And then bagging improves performance stability of a model by separately modeling different data samples and then combining the results. I mean, I'm kind of,
Oh, yeah.
I'm kind of married to bagging on that one.
Okay, I agree.
Okay. Thank you. And then for the ensemble approach, forces the model to pay attention to the records where the model makes errors. Again, that sounds forces the model to pay attention to the records where the model makes errors. Where's that random forest? Random forest builds multiple decision trees and merges them together to get more accurate, stable prediction. Introduced diversity introduced by randomness compensates for the bias of a single tree. Ensemble learning models aggregate multiple machine learning models along with overall better performance. Weak. Logic behind it. Each model is used as weak when employed on its own, but strong. Decision trees acting as weak factors are used and their outputs are aggregated with the result. The process of finding the root node and splitting the feature. Pay
I
attention.
think it might be boosting.
Yeah. Combining learning algorithm in series to achieve strong learner. Sorry. This one's not the magic website, is it? Anywhere? Nope, don't see it. Okay. The ensemble approach forces the model to pay attention to the records where the model makes errors. And I'm thinking it's boosting.
I think it's boosting as well. I'm not sure if this is aligned, but on page 23 of the Ensembles slide deck, it says records that are classified incorrectly will have their weights increased, and then records that are classified correctly will have their weights decreased. So it sounds like if it's classified incorrectly, which is an error, I think the boosting pays attention to it more. Right there next to boosting.
Yeah. Ensemble approach forces the model to pay attention to the records where the model makes errors. And oops. Records that are classified incorrectly and will have their weights increased. So yeah, okay, yeah, I think that's good corroboration then. It's gonna make adjustments based on the detected errors in the learning process. Anybody have any other thoughts?
I'm not so sure about the backing, but in the slide it's saying that the symbol average is the average of the predict result from the combined model. So and backing in resample. So I'm not so sure. It's missing the average. So I think it's right.
Well, the bagging, the bootstrap aggregating is the process of taking randomized samples of randomized subsets of the data set and then training the model on various randomized subsets over and over again so that you're not
That resemble, right? That a resemble. Backend is the resemble, but the average is you combine the result of other different, the average. Yeah.
yes.
So
Yes,
that is the one that you combine.
well, I mean, I think the word combining is all over this chapter because that's the nature of the ensembles themselves. I don't want to get laser focused on that one word when I'm looking more at the
Different model.
yeah, this part, the modeling different data samples
Yeah,
separately and then
separately.
combining them in. That's kind of that's got bagging written all over it to me.
Okay.
I originally had average too, but yeah, I'm just not sure. I just wish it didn't say different and separately. I don't
Yeah.
know.
Yeah. For simple averaging, it's the simplest approach for creating an ensemble, combine the prediction, classification, or propensities from multiple models. But it doesn't say anything about different data samples. But in bagging, based on averaging across multiple random data samples, and then combining the results. So, I mean, everything, the averaging talks about one aspect, bagging talks about all three.
Yeah, that makes sense.
All right, shall we run it from the top and just do one final walk through here? Bagging known for sampling with replacement. Anybody have any reason to argue against that?
I know we were just gonna do a run through, but I submitted my quiz, so if we want to take a look at mine, we can do that and
Yes,
as a
ma'am.
run through.
Okay, Samantha, thank you very much for volunteering for that.
No worries.
Go ahead and share your screen when you're ready.
Can you guys see my screen?
Yes, ma'am. Oh, okay.
Okay, so I got an 11 out of 15. So number 1 was incorrect.
What is what? But it doesn't give the answer. That's
Mhm.
okay.
Number 2 is correct, decision tree. Number 3 was incorrect. You want your learning rate to be low so that you decrease your opportunities to jump from optimal solutions, but you don't want it too low because there are too many resources. So I guess it's
But that's contradicting itself.
That's
It's saying
exactly
it should
what
be
you
low,
have
but not
up.
too low.
That's literally our answer.
The actual.
I haven't, I think number 6 is the same thing. Like I think it's contradicting a little bit. So I'm not sure. I was gonna email the professor. But
Yeah.
Her quiz might be messed up.
Yeah, I would definitely push that. The response, the answer is exactly what you have up there.
yeah. Number 4 was correct. So that is yes. The sometimes is depends on learners is not correct.
Okay.
Number 5 is 1 and 2.
That's 1 and 2. Okay.
Number 6 is the same thing. It says it's wrong, but we can create an ensemble by following all or any of the options above.
Oh my God,
Well,
what is it?
I'm gonna keep 1, 2, and I'm gonna keep the answers because I mean I believe that that's exactly what they're saying. Yeah, and I would kind of dare anybody to say that that's not the exact answer.
Number 7 was incorrect.
Okay, now I had false for number 7. Ensemble learning can only be applied to supervise because, and you put true.
So I think this is correct based upon their response here that it is false because it's saying that you can use it for unsupervised learning as well. So that is false. And then the rest are correct. So number 8 is false. Number 9 is 1 and 2. Number 10 is false. I mean, it's true, sorry.
Okay.
Number 10 is true. Number 11 is 1, 2, and 3.
2 and 3, okay.
Number 12 is picture number 1.
Yeah.
13 is false.
Yeah, okay.
And then 14 was correct as well. Bagging and boosting.
Okay, all right. I'm submitting mine with those 2, 6 and
Wait, 1 was still incorrect. Or are we saying that 1 is sampling with replacement?
oh yeah, okay. So 1,
Would 1 be all of the above then?
I have no idea.
Huh.
That's what I thought.
What did your feedback thing say?
I didn't give the answer. It just said
I'll post it in the chat.
Okay.
This is for number 1.
Interesting. Okay, it's kind of big.
If it was me, I would go with all of the above. Like when I first did it, I was thinking it was between sampling with replacement and combining multiple weak learners into a single strong learner. But at the same time,
maybe it's that one because for sure it can't be sequential, right?
I
Bagging-
just submitted and it's all of these.
okay.
And for number 3, I tried a different answer just to see, and it's going to be one of the ones that says high. Either the learning rate should be as high as possible or should be high but not too high. But I got the same thing like in the feedback thing that it should be low, low. So I just think she messed up with what the right answer was for that one.
I submitted mine and some of the same questions, like I got them counted right. So maybe there's two versions of the quiz.
I wonder
Okay,
if
dude, for your number 3. Sorry.
For number 3, I got the low, like the one low but not too low, and it was counted right, which is
How is
weird.
your question worded?
Yeah,
Which of the following best practices, which of the following best describes the proper approach to use the learning rate to get an optimum output in the boosting technique?
I have the same exact question.
Same exact question, but you got a different answer, huh? Or yeah, I mean, you got to you submitted the same answer we did, but you got that marked wrong, and Bailey got that marked right.
Mm-hmm.
Okay, yeah, there's a functional problem there with this quiz.
Yeah.
What about number 6, Bailey?
Number
Was it-
6, 1, 2, and 3.
What was the other one that we were talking about that was
Did you get it right though, Bailey? Number
Yeah,
6?
it counted it right.
Yeah, number 6, I tried a different answer. I tried 1 and 3 and it counted it wrong. So what I'm thinking is there are technically 2 versions of the quiz, but she messed
Mhm.
up somewhere where she created the quiz and some of the answers are being counted wrong, although they're correct. And the
Right,
other way
like
around.
the key for one is being used on the other.
Yes,
Yeah.
exactly.
Yeah, Bailey, for number 1, what did you get for 1?
I got it wrong just because I was careless, but I didn't switch from sampling with replacement. I bet it's all of the above.
Well,
Like all of
Miriam
these.
put all of the above, and that was right.
Yeah. Let me go ahead and share my screen real quick.
Okay,
I'm gonna go ahead and submit mine. Let's see what happens.
all right,
There we go.
fingers crossed. Okay, so all of these, you got that, all right.
Okay, I got all 15 points. No, I lied. I got 12 out of 15 points. Number 1, I put all of these and it's incorrect.
What?
Number
You probably have the other version that
I'm thinking I have the same one because my number 3 is the same exact thing. And then
you got it
my
wrong.
number 6. Like I literally have the same exact thing, saying that they're wrong.
Okay, so there's a 50-50 chance for anyone else here that you will have either quote unquote quiz 1 or quiz 2. I would say select the right answers.
Yeah.
Because just in case you do have the right quiz, you'll get all of them.
Okay. All right,
If you
I
have,
got-
She'll fix it. It's not
Yeah.
hard to fix it.
yeah,
Right.
I
I'd
got
rather
50
submit
out
the
of
right
15.
answers and have it be wrong so she can fix it than submit the wrong answers and seeing if it's right.
Ah,
Well, I submitted wrong answers, so I really can't do anything about that. But whoever did submit the right answers can argue like, oh, why did you say it was low on your feedback? But when I, put it as an answer, blah, blah, blah.
I chose.
But then again,
low,
I know
low.
she lets us collaborate on the quizzes, but I also don't want to make it seem that, we're just really sharing the answers with each other, especially because, the internet really
Well,
will do this one.
I think these videos are evidence of that, that we are working through them and we're trying to look at different, even if we have a, supportive website out here, we're still doing our part of tearing them apart and trying to make logical sense out of what we're getting, not just taking an answer and slapping it down. For number 3, I chose low, and I got the full points for it.
Okay. So
I got-
I'll email her.
yeah. Oh, so how many of us chose the right answers but got 12 out of 15?
Megan,
I got 12 out of 15.
Should we all email her individually or?
I think as a group would probably be a little bit better. I mean, and you can use the email that the distro list that I use to send out the invitations and the videos. Because it is a class issue. The entire class is going to be impacted by it one way or another.
That's true.
Well, I think something similar might have happened with one of my other quizzes as well, because I knew a couple answers were right and then counted them as wrong. So I just don't think she's paying that much attention to when she creates a quiz. She's probably just creating 2 random versions. And for this case, the key just wasn't matching since. You know, there's no
I-
new questions. We all had the same questions. And, you know, sometimes we have at least 2, 3 different questions. So,
I talked to her yesterday and she said that there were, she inherited the class curriculum from some other professors that are no longer here. And so they've been doing a lot of trying to reconfigure the way that things have been done. So there's probably just some latent, you know, errors and issues from the way it was administered in previous semesters. I'd be willing to give it the benefit of the doubt, but I mean, with also when you have a 16-week course crammed into 8 weeks, then all kinds of other craziness can happen as well. But she
Okay.
is fair, so I think if we send her an email, letting her know what the discrepancies are, then I think she'll be fair and correct them, or at least address them and give the points back.
shall we move on to the next quiz then and
Let's
hope this
move
one
on to the
doesn't
next quiz. Yeah, let's-
cause us to lose our minds?
Who's gonna email her?
I can, but it won't be until afterwards. If anybody wants to do it while we're going through the quiz, then
Yeah, I'm
would
putting
be-
Jordan to bed.
what's that?
I'm putting Jordan to bed. I can do it after if nobody else wants to do it right now.
I think it should probably be someone who got
Right.
who missed
Yeah,
them.
all of them,
Yeah.
right? I agree.
So who all got them wrong? Me, Christian, Samantha.
Samantha.
I
Yeah,
got mine wrong on purpose to try to get the points.
I got it wrong too.
What happens is when she corrects the key, it corrects the key automatically for everyone. So it would probably just take one person like with some screenshots and explaining it clearly, and she'd update the question for all of those quizzes and it would automatically apply to everybody else.
Well, I am about to tell y'all there's no guide, there's no Yoda for this next quiz.
Oh, okay, we're
Oh
on our,
no.
that's all right. That's all right. Thank you very much.
Tony is back to being the Jedi here. So
Oh, God help you. Where are you, Antique Gupta? You are.
I know,
our-
right? I'm telling you, he disappeared. He knew
I
too
know.
much.
Nice guy. Appreciate him. All right. We'll include. I haven't even know. This is the first time I'm opening this, so I am at a complete disadvantage. But cluster analysis, chapter 15. Let me get to my tabs here. And then do I even dare close the ensemble PDFs, or do I keep those open because something might show up in there that we need to know?
I don't think so, because cluster.
I know, but we found some answers in some weird places, man.
That's true. The first one isn't bad. You're just really looking at those 4 graphs, and I can explain it if
Yeah,
want.
yeah, lay in, go ahead.
so. For the first cluster, the choose between those 4 options, it for sure is not the most diverse because it only has 1 line. It does not have a high beta and a high PE ratio, so we can cancel that one out. And then it does have a low PE ratio, but it doesn't have a low leverage, so we can cancel that one out. So by process of elimination, it is high beta and leverage, which it does have, even if
Okay.
you wanted to be confirming on that. So yeah, it does have.
Yeah, it's got the highest beta and it's got the highest leverage. Yeah. Yeah, I'd say that's a
And
good process of elimination and a fair assessment.
And I'm gonna skip to cluster 3, just because I already can see right off the bat that this is the most diverse in terms of like how far it's spreading compared to 2 and 4. Because 4 does have as many lines, or if not more, but they're all compact. So it's not necessarily diverse. So for 3, I put it's the most diverse cluster, but generally characterized by high rev growth, which it does have. It has really high rev growth. Rev growth is the highest, and new profit margin, which it also has,
But then net profit.
leverage, which it does have. It has low leverage.
Oh, okay. High rev growth, new profit margin, and low average. So the
Rev growth and net profit are next to each other, and they're both high, or relatively
Okay.
high.
high, but not the highest. Okay, I was reading highest there. But it said here in the answer, new profit margin. I guess that must be a typo for net profit margin, right? Because there is no
Oh,
new
yeah,
profit margin category.
I didn't even notice that. Yeah, I guess. Yeah. Well, yeah, it must be a typo because even it has the space underneath of it.
Yeah. All right, so then
And
what do we
then
have left then? We have high beta and PE
MP
ratio.
ratio,
So
which is
high beta would be
just 2.
2 is higher than 4.
Yeah, because 4 doesn't even have a high beta or a high PE ratio. So the one that has high beta and high PE ratio is 2.
Yep.
The green chart has 2 spikes right there too.
Yes, that's what I'm referring to. Sorry.
Yeah. Yeah. Okay, so then 2 has high beta and PE ratio. So then by virtual elimination, 4 is the low PE ratio.
Which it does have. It has a low PE ratio and
Yeah.
leverage. It has a really low the lowest leverage.
Well, is it the lowest? Because if you look at 3, oh wait, no, there's 5 models there. No, I'm sorry, never mind. Ignore me. 1, 2, 3. I was looking at this one up here.
I did the
That's
same
fine.
thing at first.
That's fine. 1, 2, 3, 4. That's the cluster means. Okay, yeah,
Yeah.
I got it.
That's it.
Okay. All right, so then true or false? Clustering is a supervised learning approach.
F plus. It's
false.
It's unsupervised because you get to choose. Sorry, you don't get to choose. How to say it?
The target variable. There is no target variable in this clustering.
Right, okay, yeah, fair point. I'm just looking in the book, just making sure, just seeing supervised or unsupervised. I don't know why I go back to the book because I'm trying to really struggle to remember if there's ever a question we answered from the book. All right, I will accept false with a flag. Number 3, the choice of which distance measure is used will not affect the clustering behavior. That's
Hey,
false.
Tony, a couple of us had a different number 2.
Oh, okay, please. I'm sorry if I missed it in the chat.
So I
It-
do, but my 2 and 3 are just switched with Tony's.
Okay,
You guys, or do y'all have completely different questions?
I think mine are completely different.
Okay.
all right, baby, what's your number 2?
It's a true or false. It says the choice of which distance measure is, the choice of which distance measure is used will not affect the clustering behavior.
Okay, well then you're just like Megan, because your number 2 is my number 3. That's what Megan was just saying.
Oh, okay, sorry. I put false.
My number 2 is also different.
What's your number 2?
So it's also a true or false. So it says when conducting an hierarchical clustering algorithm with using the word method, we made sure to select the standardized data option to make sure that the distance measure was not dominated by variables. Yep, that one.
I have that one as my number 3.
Oh, that's your number 3. Yeah.
Okay, so So William and Christian have their questions reversed. Megan and Bailey have theirs reversed from mine. So we have what, three different quiz versions now. So we have to be careful.
My number
Also,
3 is a completely different question though.
your number 3 is completely different. Okay.
Mhm.
All right.
Tony, I'm with you.
The ones that you have, and then we can fill in the ones that aren't on yours.
Yeah, but I think that we're gonna have to do that. We'll go through mine, and then we'll go back through a couple more rounds of the deviations and address them, because I'm gonna start bouncing around and get
Sure.
myself even more confused than I am.
Sounds good.
Okay. Just let's be very mindful of not just the order of the questions, but how these questions are worded, because I get the feeling this is gonna be one of those, you know, gotcha quizzes, maybe like all the other ones have been. All right. So I got false for both 2 and 3 out of that whole conversation. Is that the choice of which the distance measure for clustering, measuring the distance on page 359. Distances can be defined in multiple ways. Normalizing other distance measures. Important note, the choice of the distance measure plays a major role in cluster analysis. So the choice of which distance measure is used will not affect, that's false. Okay, I am page 360. I actually found an answer to the question in the book on page 360 under other distance measures for numerical data at the very bottom. So put that in your pipe and smoke it. So for number, any arguments or questions about 2 or 3? Before I go.
Can you read the part that you said again from the book, or where you
Yeah,
got that?
on page 360 at the very last 2 sentences. It is important to note that the choice of distance measure plays a major role in cluster analysis. So by that, when it says the choice of which distance measure is used will not affect, I'm saying false because the book says it does.
Yes.
In black and white.
Yeah, Tony, I put the same.
Outstanding. Thank you. All right. Which of the following, number 4, my number 4, which of the following is not a measure of distance between clusters? Now I know minimum is, I know average is average?
Yes.
I know, yeah, and then so is maximum and so is centroid, so gradient distance is not.
Oh, my options are different. Even.
What are your options, Joel?
Your question probably says which is the most popular.
Yeah, that's true. Yeah.
Is that what you have, Christian?
Yes.
Okay.
So Euclidean, right?
Yes.
Euclidean, yeah. Okay, does anybody else who has the same question I do have the same answers in the same order or different answers in a different order?
Oh. My 5 is your 4. My question number
Same.
5 is.
Okay, your 5 is my 4. Okay, I got you.
Yeah, same here.
Same answer.
All right, so good. Then my number 4 just answered your number 5.
Yes, that's correct.
Okay.
Yeah, I have selected.
Fantastic. I like when that happens. That's rare, but I like when that happens. Number 5, my number 5 is alive. Which of the following is required by K?
No, guys. Hello? My 4 is actually different. Maybe someone else has it. So it says, which of the following is required by K-means clustering? So you
Well,
have
your 4 is my 5. I'm addressing my 5 and your 4.
Oh,
right?
okay. Okay.
Yeah, that's all right. So the k-means, which of the following is required by k-means clustering? And k-means, I saw that. Well, it's in the intro on page 355, but initial guess on clusters, a number of clusters, and a distance metric. Which of the following is required by k-means?
Number 3.
Yeah, put all the above. No.
Is there a, I'm trying to find it in the book.
I think I found it in one of the slides. Let me
One of
look
the
for-
slides, okay. Single linkage, average linkage, complete linkage, validating clusters. The k-means algorithm is on, starting on page 374. And it starts with initial partition of records, initial guess on the cluster centroids, number of clusters, and distance method. Reduce the sum of distances, modification, allocating each record to the nearest K centroid. Yeah, initial guess on the means of new clusters are computed and improvement step is repeated. Choosing the number of clusters. There that is. And then a distance metric. Different values for K, resulting clusters, external reasoning. K-means cluster centroids.
On the clustering PowerPoint on slide 37, it says often based on random selection of K centroids, which sounds the same thing to me as initial guess of cluster centroids.
Yeah, choose number of clusters. There's that one. Let me widen this out a little bit. Oh. Okay, so we have number of clusters, partition, the centroid, and does it say anything about the distance measure?
The distance part is one I can't find.
Well, you know what? If it mentions 2 of the 3, then I would say that it's probably a safe bet that the third one's out there. So I'm willing to go along with all the above. Because we can already identify centroids and clusters in the requirements. And even if the distance measure is not listed now, it's got to be out there somewhere. Maybe on another slide. Different choices for K. What happens to the distance between clusters? So it's already addressing the distance. So yeah, I'm going to say all the above on that.
Yeah, you could go to the cluster analysis deck as well. I think it's slide 9. It says choosing K, assign data points to the closest cluster center, and change center to the average of the assigned points. So to me, that sounds like a distance thing. This is talking about assigning
Yeah.
points to the closest.
Yeah,
Hmm.
cluster centers, centroids. Okay, I'm cool with with all the above there. I think that makes the most sense. Number 6. How many questions are there? 12? Okay, well, that's not bad.
Very colorful.
Very colorful. You have fit a k-means algorithm with 6 clusters. The results are visualized below. Based on the plot, which statement is true? There is overlap between many of the clusters, which indicates there is no significant difference between some clusters, and as such, fewer clusters should be evaluated. Or there is good separation. I wouldn't say that's good separation. I'd say that it is overlapped and blended. No need to try and fit a different number of clusters. I don't agree with that. There is a good separation between the clusters. Each cluster is similar to each member in the cluster, but appears to be different from other clusters. There is significant overlap between many of the clusters, but the added complexity is providing adequate separation. That one actually has some merit in my brain.
Yeah, for sure it's not that good separation, because obviously that there is overlap. I just didn't know if it was significant overlap or the other overlap answer.
It's like either overlap with no significant difference or significant overlap, but the added complexity of providing adequate separation. And the color groupings, I mean, they are separated. There is overlap and there is blending, but there is separation.
Yeah, it's hard. I feel like looking at it, they seem pretty distinct, like distinct enough, but I'm not sure what she's looking for.
Yeah, that one's a gotcha on the wording of that. We'll come back to that. We'll let that one simmer for a minute. Number 7, which of the following tasks might clustering be suitable? Given a database of information about your users, automatically group them into different market segments. I'd say that is a contender. Given historical weather records, predict if tomorrow's weather will be sunny or rainy. I don't think so much there.
We have a target, so you can cancel that part.
Yeah. From the user's usage patterns on a website, identify different user groups. That one's got.
Yes.
And then given sales data from a large number of products in a supermarket, estimate future sales for each of these products. Again, that's a target variable, right, Sajal?
Yes. I have doubt on the first and third in your options.
I was thinking the first.
Yeah.
Okay.
I mean, both of them qualify
Yeah.
at their core.
Right.
I think that the database one is more of a black box.
Okay.
Whereas the usage patterns, that would be something we were interpreting.
That's specific, yeah, not the database thing is kind of ambiguous, right?
Then the database.
Yeah, I like that, Bailey. That's more of a definitive sample. We're talking about usage patterns versus database of information. So yeah, I like that. I think that's something that she would try to get us hung up on. All right. Number 8, there are 2 general types of clustering. Match the type to the general definition. Hierarchical.
Yes, the second one.
Is the agglomerative one, right?
Right.
Yeah.
I selected that one. Yeah.
Yeah. I remember because I was just looking at the agglomeration on.
Yeah, because the agglomerations starts from a bunch of them and then ends up with one, and divisive starts with one and ends up with a bunch.
non-hierarchical observations are assigned to each cluster. Okay. All right, and number 9. Complete the following sentence. K-means clustering is. I don't know if it's always guaranteed to do anything, especially LEED to an optimal set of clusters.
That question for me is my 12.
Okay, all right.
And I put an unsupervised machine learning algorithm.
Me too. Yeah, it's my number 10.
Okay.
I don't have that one.
Okay. Do you guys want to look at or go over your number 9 or?
Oh, we can go later also.
Yeah, we can finish your course and then jump into the other 2 variations.
Okay, all right, fair enough. Number 10, how are the initial centroids for K clusters determined? Based on the point that maximizes, I was just looking where
It's random.
centroids. It is random, right?
Yeah, it was in that slide that we were looking at earlier, where we were trying to figure out for K clusters. It was in the other one, I believe.
Oh, the other clustering.
It was in the clustering slide. Slide 37. It says often based on random selection of K centroids. Start with the partition into K clusters, often based on random selection of K centroids.
Oh, it's on the PowerPoint slide deck, isn't it?
Yes. Slide 37.
Okay, yeah.
Number 2.
Number 2, random selection of K centroids. There it is. All right. Number 11, distance measure used will affect how clusters are formed in a hierarchical cluster. And that was on page 358, 359. Distance measure used, hierarchical K-means clustering, both cases need to define two types of distances. Distance between 2 records and distance between 2 clusters. Pre-specify number of clusters. Method assigns records to each cluster. Methods are generally less computationally intensive. Divisive method. Clusters. Distance measure used will affect how clusters are formed in hierarchical clusters. True.
That's what I put too.
Okay, yeah, that makes sense. All right, so then number 12, which hierarchical method takes a top-down approach?
So I was just mentioning a while ago.
That was Ward's method, right?
No. I thought it was divisive.
Hierarchical methods can be either agglomerative or divisive. Agglomerative methods begin within clusters and sequentially merge similar clusters into a single cluster. Divisive methods work in the opposite, starting with one cluster that includes all records.
It's in the PowerPoint.
The
Divisive. Yeah.
way I think about it is divisive. It divides into different branches.
I see that.
Starting from one and then
down, spread, dividing and dividing and spreading.
yes.
But
And
then the agglomerative is from the bottom up, combining into a single, right?
Yeah, and for that one, I just thought of aggregation.
Yeah, yeah. That okay. Yeah, that helps a lot. Okay, any other thoughts about number 12 before we go back through and address the differentiators?
That was my number 9, by the way. Your number 12.
Okay. My 12 is your 9. All right, where did the, number 1 was kind of universal. Did anybody have different questions for 2, 3, or 4?
I had a different 3 that I don't think you didn't have at all.
What was your 3? You want to share your screen?
Sure.
Okay, when conducting a hierarchical clustering algorithm using the Ward method, we made sure to select standardized data option to make sure that the distance measure was not dominated by variables whose scale had larger values. And by the time you get done reading it, you forget what the beginning of it even said.
Well, I know for sure, whenever you're talking about hierarchical, you do want to standardize the data.
Yeah.
And then that distance measure part, I feel like that kind of backs off from that question that you had. I think it was your question 3.
My 3 was the choice of which distance measure is used will not affect the clustering behavior. I said false. So your distance measure was not dominated by variables whose scale had larger values. I do think true is a good answer.
Because we don't want distance to be a factor to affect.
Right.
And your question was saying that distance.
The choice of which distance measure is used will not affect the clustering behavior, but that's false.
It does affect it, right?
It does affect it, yes.
If it does affect it, we want to avoid it.
Yes.
We want to avoid.
The distance measure was not dominated by variables whose scale have larger values. That you have the distance measure, it is important, but it's not dominated by very large scale values.
Yeah.
Yeah.
And that was the only different one that I have from you.
Okay. Anybody, let me go back to sharing there. All right, anybody have a different 4 or 5?
My key is very different than yours, Tony.
Your what?
My key, my questions are very different than yours.
Do you
I
want
think
to
it'd be best if you put the screen for that quiz. So there's 3 versions. So
Okay, I'll share.
Okay,
Let's
yeah.
see.
what's version number 1 per se? And then this is version number 2.
Okay, can y'all see my quiz?
Yep.
Okay, so question 1 was the same. Question 2.
Yeah.
Okay, and question 3, when your measures are in different scales, you should normalize or standardize the measures before applying the clustering algorithm. I put
Yes.
true.
Yeah, that's
I
true.
go with true too.
Yeah,
Okay.
that pretty much co-aligns with my question 3.
Okay.
Cool. And then which of the following is the most popular? Is it Euclidean?
Yeah.
I go with that too.
Yes.
Okay. And then gradient, I know y'all had that question too. And here's the fuzzy, colorful one.
Yeah, number 6. There we go.
Oh boy. And I put that one too, but I'm just like not 100% sure.
You said there was the significant overlap, but added complexity provided adequate separation. Yeah, okay. Yeah.
And it's like, I just don't know, like, because with K, right? Can you think of how like one fewer cluster might be a better model? I don't know, it's driving me crazy. And then for 7, which of the following tasks might clustering be suitable? We talked about that one.
Yeah, I said from the user's usage patterns on a website, identify different user groups, and you have given a database. Yours, are you, now,
I put because it's not going to be interpretable. So this seemed more like a black box to me.
you're saying it's more suitable because it's not as interpretable?
Yeah, sorry, maybe I'm confused with last week's content. So are these black box models or this week clustering? Will we be able to explain the usage patterns? Or do we just kind of get,
See,
you
I
know-
thought you were saying that it was more suitable because in that first one, you have specific user usage patterns instead of a generic database of information. So I thought you were saying that your one was a better answer than your number 3.
oh, no, I think we got opposite conclusions from similar information. I'm open to either one of those. Yeah, I'm open to either one.
Okay, any tiebreakers out there between 1 and 3, between usage patterns and database of information? Because I was all for database of information, and then I thought Bailey convinced me about user usage, and now I'm stuck.
Oops.
I put this one, that database information.
You did the database?
Yes.
Okay.
Okay, and then 8, there are 2 general types of clustering. That's
Hierarchical.
one we had, right?
Yep, we got those the same.
Okay,
Minimize.
huh? Am I going too fast?
I don't think so.
No. Good.
So
Joel,
Joel,
I think your
are you saying
audio is
something
going
again? I
out.
can't hear you.
Yeah, I'm good. Yeah, you can go ahead.
Your question 9 is actually my question 11.
Okay, did we decide it was intercluster variant? When applying K-means clustering, what is the objective function?
That's correct. It's in the,
It's intercluster. I believe it's intercluster.
it's intra-cluster, minimize the total intra-cluster variance.
Intra, okay.
Intracluster, the first number 1, the intracluster variant.
And
not
that's,
variance.
and
Yeah,
that's,
It's variance.
that's between clusters.
Cluster, yeah, minimize is on the PowerPoint.
Okay, and intra. So inter is like inside of the same cluster, and intra is between
It's
clusters.
between, yeah.
Oh, intra is in one, and inter is between, right?
Yes.
Like interstate and intrastate, yeah.
Okay, thank you so much. Okay, 10, complete the following sentence. K means clustering is unsupervised. How are the initial centroids for the K clusters determined randomly and divisive?
Yep,
All good?
all good.
Okay, I'm gonna stop sharing.
All right, anybody else have any other differentiators?
I do. I can share my screen.
All right, go right ahead.
Let me. Okay. So this is the same question, same
Number
graphs and
1.
everything. I have this for number 2.
Number 2, when conducting a hierarchical clustering algorithm using the Ward method, to make sure to select, and this was the one Christian had.
Yeah, that was my last question.
Yeah, and that was true.
Yes.
Miriam, you still there?
Yes, sorry, I blanked out for a second.
Oh,
You're saying true?
True, yeah, that's what we
Okay.
determined.
The coffee's wearing out. I'm sorry, guys.
Oh yeah, I don't doubt it, man. I'm due for mine too. I need a caffeine booster.
And then this question was also on Bailey's, but it was a different
Yeah, when
question.
your
It was like
measures were
her number 4 or 5.
you should normalize the standard or standardize the measures before. Yeah, that was true. Yeah.
Okay. And then these are the same, just a different number order. Yeah, and then this color spaghetti.
Yeah,
thing.
yeah. That swirling nightmare of color.
Honestly, at least it's nice colors. Like I've seen
is pretty.
graphs that have like really dull colors, and this is like neon. You know, it's entertaining to watch.
Yeah. It doesn't give any indication as to what the correct answer is, but it is pretty to look at.
I mean, I will say these clusters are more, you know, together per se, and then, you know, the purple cluster is just doing its own thing.
Yeah. The
So
question is it significant overlap with adequate separation, or is it overlap but no significant difference between some clusters?
I know for sure it's not this first one,
Yeah.
but I'm thinking it's either the one we selected or this one.
I mean, the
You think
green and
there's-
yellow are pretty on top of each other.
Yeah, I'm thinking it's either your 2 or 4, but I'm still leaning more towards that number 2.
Number 2. Okay, well. And then I think this one we all had. Same with this one. Same with this one.
Yeah.
Same
Your
here.
11, the distance measure. Yeah.
Yeah, that's pretty much it.
Okay. All right. Anybody else? Any different questions, different orders, different words, different tears of joy and agony?
Who gonna submit?
Who hasn't submitted first yet?
I
huh?
did. I panic submitted
I know-
multiple times last week.
I know. I got you. Let's see. Raj, William.
I got 13 out of 15.
Woo! You want to
Woo!
share your screen?
You want to share your screen there, Mintu?
Okay.
I could submit mine too. That's not a big deal. Sorry, I was away from the laptop. I heard my name.
You got to pass on this one, unless the questions are really way off.
Okay.
All right, so number 1, yeah.
Oh, good.
Cluster 1, high beta PE, most diverse, low PE, good. Numero dos, false, good. Oh wait, can you go back
I
up the
have
number?
different question with you, Tony. I
Yeah,
think I have the same question with Barry.
yeah. So that's good. That number 3 is true. So that's great.
Mhm. So number 4 is.
Number 4 was the gradient distance.
Mhm.
Yep. I had a different number 5. Okay, so number 6 is not significant.
Slide 19.
How is it? Okay, slide 19 of the cluster.
Slide 19 of the cluster analysis lecture.
So it must be there's overlap between many of the clusters.
Yeah,
I agree.
Yeah.
Okay. Number 7.
number 7, given a database of information. There you go, Bailey.
You want me to shake?
Now we know.
Yeah. Number 8.
Number 8 is 10. Okay, good.
Yeah.
Number
Wait, sorry.
9.
What was 7? The
7.
database one?
The
database.
database.
Yeah.
Okay, yeah, that's what I had as well.
Okay.
Number
That's what I
9.
had initially until Bailey confused me. I believe
Oh,
it.
I don't know why number 9 is wrong. It's right.
Let's see. When applying k-means clustering, what is the objective function?
Oh, we just
It's-
talked about this. It's actually minimizing the intra-cluster variance.
Yeah, it's
In-
minimized, not maximum.
Yeah.
Maximize.
It's why?
Different
was
order,
just-
I bet.
It's just it's just a word play there, Mintu. I'm sorry.
Okay, number 10.
Number
Yeah.
10 was randomly.
Mhm.
Number 11 is true and divisive. Okay.
Yeah, so, okay.
All right.
You are good? Okay.
Yeah.
So then mostly the cluster one is the one we have no clue.
Yeah, well, I submitted mine, and I chose for number 6 that overlap between many of the clusters, and that was right. I got 15 out of 15. Let me, if you haven't submitted yet, hold up. And
You say as I panic submit.
I
Why,
also submitted, I also submitted.
why am I like this?
I don't know. Why are you like that?
Ah,
I've been wondering that
There's
myself.
number 1.
Did you at least get them right, Miriam?
Yeah.
I got one wrong, I think. Let me double check.
Number 2 is clustering is a supervised learning approach is false. Number 3 is false for which distance the choice of which distance measure will not affect. That's false. Number 4 is gradient. Number 5 is all the above for the k-means clustering. Number 6 is the overlap. No significant difference between some clusters. 7 for which of the following tasks might clustering be suitable given a database. 8, I think we all got that, hierarchical and non-hierarchical.
I actually got 7 wrong because I forgot to change it. That's the one I got wrong.
Number 8, number 9 is an unsupervised. 10 is randomly. 11, distance measure used will affect how clusters are formed is true, and 12 is divisive. So anybody have any questions about the quizzes? Now, does anybody have any interest in going over the labs tonight, or the lab work tonight? Because I have to drive out of town up to Frisco for school tomorrow, and I don't want to have to do the lab when I get back. So does anybody have any interest in doing it tonight, preferably after maybe a little half-hour break?
I already did the first part, the one that doesn't tie to the baseball one.
Okay.
And the cookies one. I already did that other one that I think it relates back to the German credit data. I did that part, but I haven't done the second part.
Okay.
I can work with you, Tony.
You want to work? You want to do it? Can you give me about a half hour, and then I'll be back. All right.
Yeah.
Cool. Do you want me to leave the? I have to actually leave. Do you want me to leave the room open, and I'll just be back in about 15-20 minutes? I can leave it up and running.
And Tony, will
I think it's
you record it?
Stop the recording so it's not.
Yeah, I'll stop the recording right now. I'm going to stop sharing, and I'm going to stop recording.